We are going to start with electrochemistry. And when we talk about electrochemistry, it's really talking about the movement of electrons. It is the movement of electrons. It's similar to when we talk about acid-base chemistry, how we have the movement of that proton, and we have something that will accept the proton, and we have something that will donate the proton, which is a base and an acid respectively. It's very similar in electrochemistry. But in electrochemistry, we call it a redox reaction instead of a neutralization reaction. And that redox reaction is that transfer of electrons. So there are two things going on. We have a reduction process that is happening, and reduction is the gain of electrons. And then we also have oxidation happening. And oxidation is the loss of electrons. Now, these two processes have to happen together. You can't have something be reduced without something else being oxidized. They have to happen together. If something is being reduced, it means that it is gaining electrons. Well, that electron has to come from somewhere. It's coming from the thing being oxidized, and they happen simultaneously. So just like acid-base chemistry, where you have that transfer of protons, you have to have an acid, you have to have a base. You have to have something donating a proton, and you have to have something accepting the proton. With redox reactions, you have to have something donating the electron or losing the electron, and you have to have something that will accept it or gain that electron. Now, through the reduction process, it's going to result in a decrease of oxidation number. And the oxidation process results in an increase of the oxidation number. It's very important that you know how to calculate oxidation numbers for any element. If you don't remember how to do this, there is a worksheet on Canvas that you can use to remind yourself. Now, in this process, something is being reduced and something is being oxidized. Well, we have different things that make that happen, and we call that the reducing agent and the oxidizing agent. So the reducing agent gives electrons to the substance being reduced. It gives electrons to the substance that is being reduced. So what that means is this is actually the thing that is being oxidized. So the reducing agent is something that causes the other species to be reduced. And that means that it loses an electron so that the other species can gain an electron. So the reducing agent is actually the thing that is being oxidized. Now we also have the oxidizing agent. And the oxidizing agent takes the electrons from the substance being oxidized. So what that means is the oxidizing agent is the thing taking the electrons and it's causing the other species to be oxidized. So the oxidizing agent is actually the thing or the species that is being reduced. So let's look at an example. When we look at the reaction between solid zinc and hydrochloric acid, we get zinc chloride plus hydrogen gas. Now, what I like to do is identify if this is even a redox reaction. And I think the easiest way to do that is to look at if there is a change in the oxidation number. So remember, every element in its elemental state has an oxidation number of 0. So I'm going to put a 0 by the zinc and the hydrogen. Now, most oxidation numbers in ionic compounds are just going to be the charge of the cation and the anion. And then in molecules, hydrogen will be +1. So here, my hydrogen is going to be +1. That means my chlorine is -1. Zinc is +2. Chlorine is also going to be -1 again. Now, if there is a change in oxidation number, then you know this is a redox reaction. So zinc goes from 0 to +2. Hydrogen goes from +1 to 0. Since they're changing oxidation numbers, we know that oxidation and reduction have to be taking place. So let's look at zinc. Now, zinc is going from an oxidation number of 0 to +2. The only way to achieve that is by losing electrons. So zinc loses 2 electrons. So what that means, since it lost electrons, it is going to be oxidized. Now let's look at hydrogen. Now hydrogen goes from +1 to 0. The only way for it to do that is to gain 1 electron. And since it is gaining electrons, it must be reduced. Now, you cannot have redox reactions where two things are being oxidized or two things are being reduced. If we know for certain that zinc is being oxidized, then that means hydrogen must be reduced. So now we can look at the agents. If zinc is being oxidized, that means that zinc is the reducing agent. When zinc is oxidized, it loses an electron, and that causes the hydrogen to be reduced because hydrogen will take that electron. Similarly, hydrogen is the oxidizing agent. So hydrogen is gaining an electron, which means it is taking that electron from somewhere else, which is causing zinc to be reduced.